We're back with our third part of Skills from First Year Chemistry 105, and we're continuing with our combustion analysis examples. And this one's a little bit different, a little bit harder. And I didn't write the example down before we get started, so I'll have to do that. Okay, so this is example number 2. And the substance that we are analyzing is called menthol, and it is made of carbon, hydrogen, and oxygen. And when 0.1005 grams of menthol is combusted, we have produced 0.2829 grams of carbon dioxide and 0.1159 grams of water. And we want to know what is the empirical formula of menthol based on these numbers. So with this one, I'm going to start with a picture. We know that the menthol is made up of carbon, hydrogen, and oxygen, and it just helps me to envision everything if I draw a picture. We know that this original sample was 0.1005 grams of menthol. So what we're going to be able to do is calculate the number of grams of carbon and then the number of grams of hydrogen present from the carbon dioxide and water, and then we'll go back and subtract to find the grams of oxygen present in the original sample. Then we will convert to moles and divide by the smallest moles and find our subscripts. Okay, so that's kind of a big picture of what we're going to do here. So the first thing we want to do, of course, is start with our grams of carbon dioxide and our grams of water. And we're going to convert to moles. So 44.009 grams for the carbon dioxide and 18.015 grams for the water. And then we'll do 1 mole of carbon dioxide is 1 mole of carbon, and then 1 mole of carbon has a molar mass of 12.011 grams. So in this example, we're going all the way to grams of carbon in the carbon dioxide. We're going to do the same thing with the water to find the moles of hydrogen. So we know 1 mole of water is 2 moles of hydrogen, and 1 mole of hydrogen has a molar mass of 1.0079 grams. Okay, so we're going to plug and chug here. 0.2829 times 12.011 divided by 44.009. Okay, and the grams that I get are 0.0072, and that's grams of carbon in the original sample. And then we get 0.1159 grams of water. So we'll go times 2 times 1.0079, and then divide by the molar mass of water. And we get 0.01297, and that's grams of hydrogen present in the original sample. So you can think in your head, all right, I know this amount is the carbon, and this amount is the hydrogen. So with that diagram, it's pretty easy to envision that all we have to do is subtract to get the grams of the oxygen. So we're going to go 0.1005 grams of total, and that's our carbon, hydrogen, and oxygen. And we'll subtract the 0.0772 grams of carbon and the 0.01297 grams of hydrogen, and see what we get. 0.1005 minus 0.0772 minus 0.01297, and that gives us 0.01033 grams of oxygen. Okay, so now we are to a situation where we have grams of everything, and we just have to convert to moles and then find our smallest moles. So we're going to take all three of these guys and bring them down. We have 0.0772 grams of carbon, 0.01297 grams of hydrogen, and 0.01033 grams of oxygen. Okay, so we're going to convert to moles, and we need molar masses. Oops, that's 9. And this is oxygen's molar mass of 15.999. So you're going to go 0.0772 divided by 12.011, and we get 0.00643, and we know that's moles of carbon, and 0.01297 moles of grams of hydrogen. And that's going to give us 0.01287 moles of hydrogen, and then we'll find our grams of oxygen, and that gives us 0.00646 moles of oxygen. Okay, so it looks like the moles of oxygen is the smallest. So we're going to divide all the moles by the smallest moles, 0.00. Let me just make sure I got that right. Yep, 0.000646. We're going to divide all these by that. And that's going to give us 1 here. And that gives us 20 here, which is a pretty big number. 0.000643 divided by 0.000646. And we can anticipate that that's going to be 10, I believe. 0.000646. Yeah, 9.95, that gives us 10. Okay, so our empirical formula comes out to be C10H20. Oh, sorry, that's kind of squished over there. 1 oxygen to 20 hydrogens and 10 carbons. And that is our total example for combustion analysis, and in a situation where you have carbon, hydrogen, and oxygen. So that's a nice long example, and if you have any questions, you can post them in the comments. Thank you very much. Have a great day.